Welcome to today's discussion on the Bootstrap method and its applications in data mining and model evaluation. Let's dive right in. We'll start with an outline of what we're covering today. First, we'll talk about the concept of bootstrapping and what it is. Then, we'll move on to some practical applications of bootstrapping in statistics. After that, I'll show you how to implement bootstrapping in Python with a quick code example. Finally, we'll discuss how the Bootstrap method is used to evaluate models. And we'll wrap up with a summary of key points. Bootstrapping is a resampling method. It involves generating simulated samples by drawing with replacement from an existing dataset. This technique is especially useful when you lack information about the larger population but still need to estimate variability or parameters. Bootstrapping helps create confidence intervals or validate models using resampled datasets. In terms of applications, bootstrapping is incredibly versatile. It's commonly used to estimate the variability of statistics like the mean or median. It's also handy for generating confidence intervals when analytical solutions are impractical. Beyond that, it's a great tool for model evaluation. It helps estimate the error distribution using multiple resampled datasets. Next, let's look at how you can implement bootstrapping in Python. While I won't go through the code line by line, I will explain its purpose. This example uses the resample function from sklearn to create a bootstrap sample. The process involves taking an original dataset, resampling it with replacement, and printing both the original and bootstrap samples. This snippet shows just how straightforward bootstrapping can be with the right tools. Now let's talk about using bootstrapping for model evaluation. The process involves 4 main steps. First, you draw bootstrap samples from the dataset. Second, you train a model on each bootstrap sample. Third, you validate the model using out-of-bag samples. And finally, you analyze the distribution of errors across the models. One of the big advantages of this method is its robustness, especially for small datasets. It provides a reliable estimate of model error, making it an excellent tool for data scientists working with limited data. To summarize, bootstrapping is a powerful and flexible statistical tool. It allows us to estimate variability, create confidence intervals, and evaluate models effectively. Python's sklearn library makes implementing this technique easy, even for beginners, whether you're working with small datasets or exploring ways to validate your models. The Bootstrap method is a valuable addition to your toolkit. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.